Hey guys, Professor Bob Rosenfield. I'll be teaching you this online version of ornithology, summer ornithology. And right now it's mid-May, and I came down out of the trees to put a few things here on a videoscape so that you guys can get some very important predicates about anatomy of birds that pertain to this module, which is a lab manual that you can see on Canvas. And these pages that I'm touching, this first page, this second page, the bottom of this third page, this page 4, and especially page 5, which is the endoskeleton of birds, is something I need to do as soon as is possible, and that's why I want to have you guys grasping some of the specifics. You'll need to know all of the bones, and I'm going to go over those with you right now, and I'm going to add one bone. So, this is a skeleton here of a chicken, a fully grown chicken, and I know it is because of the spurs here on the leg bones. This animal is has an endoskeleton, as all birds do, and that endoskeleton has 3 premier functions. Number 1, it's for support. Number 2, it's for protection. And number 3, it provides surface area for the attachments of soft tissue and especially muscles. So what I'm going to do is I'm going to go over all the bones that you guys are going to be responsible for. So I encourage you to look at your lab manual sheet. I guess that's page number 5. And I'll go over all these bones, and these are bones that you will be tested on, I assure you, later on, the last week of classes, if you will. So, this is called an anisodactyl toe arrangement pattern, where you have 1 toe to the rear and 3 toes to the front. ANIS, aniso, means different. It refers to the asymmetry. 3 to the front and only 1 to the back. Digit number 1, and here are both digits. Number 1 is also known as a halix. Again, you can look for the spelling and the terms on your sheet. Digit number 1 is a halix. Lateral to the outside is digit number 4, pointing forward. Digit number 3, medial of these 3 project forward toes. And then the most medial of the 3 forward projecting toes is digit number 2. Digit 1, 4, 3, 2. This bone is known as a tarsometatarsus. Plural, both of these are known as a tarsi, or known as tarsi, excuse me, T-A-R-S-I. But each one is a tarsometatarsus. This particular bone is analogous to your heel on your foot. So a bird literally walks on the tips of it, walks on its toes. That means this joint, or these joints, are ankles. This is the major bone that you mostly see on most birds that is unfeathered. Again, it's analogous to your heel, tarsometatarsus. This big bone is and corresponds to, in effect, your shin. These are known as a tibiotarsus, and on the side is known as a fibula, tibiotarsus. This joint is a knee, ankle, knee, femur. The femur attaches to the pelvis, or the pelvic girdle. There are 3 major bones of the pelvic girdle. You and I have the same 3 bones. They don't look exactly alike. And I might add, there's a lot of fusion on an avian endoskeleton. They've dropped as many bones as they can to make themselves light for flying, and the things that they've left, they've fused to give them strength. Here, lateral and dorsally, I am touching an ilium bone. Here is an ilium bone. This is ischium. Ilium, ischium. And this long, narrow bone that this white twister is around is known as a pubis. Ischium, ilium, pubis. These are free caudal vertebrae, and they're part of the backbone. Now, this bird skeleton, which is more complete in some respects, is that of a pigeon. And if you look closely right at the end of those free caudal vertebrae, there's like one bone that kind of turns up. That's known as a pygostyle or a pygostyle. Those are fused caudal vertebrae. and all the soft tissue is attached of the tail feathers. And so when a bird turns that pygostyle or pygostyle, they can turn all the tail feathers all at once. The pygostyle is broken off of this particular skeleton. Now, before I continue, this bone that I'm outlining dorsally, dorsal means on top, this is called a synsacrum. Spelled thusly. You'll need to add this to your list of bones on page 5 for the endoskeleton. Syn means altogether. Sacrum refers to the sacral vertebrae that go through the pelvis region or the pelvic region. This is a major fusion of bone. You can't even see the individual vertebrae. If I turn this bird over, you'll notice right in here, all of these sacral vertebrae, looks like they've been melted together. They're fused to give strength to this pelvis region. One more time. Ilium, ischium, pubis, synsacrum, free caudal vertebrae. Let's go to the rib cage. The rib cage is made up of really 3 major sets of bones. Probably the most obvious ones are the vertebral bones. They're up here. And they have uncinate processes that come off of each one of these vertebral ribs. Those uncinate processes, those lay over an adjoining or adjacent rib. They give strength because there's such powerful contraction of a downstroke. These prevent the chest from collapsing. More on that in a minute. These ribs that come down and attach to this major bone, these are called the sternal ribs. Don't worry about this triangle, that's a process. But these are the sternal ribs, these are the vertebral ribs. Only the vertebral ribs have the uncinate processes. These ribs, the sternal ribs, attach to the sternum. Now in your handout it says there's a carina and a keel. That's just the extension perpendicular of the sternum bone, which of course on us is right here, but on a bird it's huge. It has to be, because the pectoralis muscle, which is the largest muscle in a bird's body, is for massive torque of a downstroke. Now, sternum, vertebral ribs with their uncinate processes, sternal ribs, sternum. All right. Here in the front are 2 bones that are fused together. You are familiar with this. It's called a wishbone, would be a common or conventional colloquial term. It's actually known as a furcula. It is fused of your clavicle bones that extend outward. And in real life, these bones, of course, when the bird's alive, are very flexible. They, like the uncinate processes in our vertebral ribs, help maintain the construct and the integrity of the chest of these powerful downstroke that occur when the wing is flapping downward. So they're like shock absorbers, if you will. Just behind them are 2 massive bones in terms of their thickness. And by the way, a term robust to an anatomist means thick. Anyway, these bones are the coracoid bones. We have no analog in our body to these. We don't need them. These are here because, again, to maintain the integrity of the chest as a result of the powerful downstroke that occurs in a bird's flapping dynamic. If you come up right here and extending backward, it's hard to see, but here is a bone that is sword-like, like a sword, and it's very flat and lies over the vertebral ribs when the wing is closed. That is a scapula bone. Scapula, coracoid, furcula, or wishbone. Wishbone's fine for me in terms of knowing what it is. All right. Now, this is a folded forelimb. Forelimbs in the majority of all the birds of the world have been modified for flight. You can't pick up things with them. So these particular bones are similar to many of the ones you have in your forelimb, although there are some marked differences. But nonetheless, the bones are very similar. The first and most proximate bone, that means closest to the body, is a humerus. Here's a humerus, here's a humerus. That means this joint is your elbow. the bird's elbow, right here. And then there are two bones in your forearm. They're the same bones that a bird has. One is a radius, that's the thinner bone, which come right off of our thumb. And the bigger one on the outside is an ulna. Radius, ulna. Radius, ulna. Elbow, wrist. Now, we have a very complicated hand. We have 5 digits. No living bird has 5 digits on their hand. They've gotten rid of 2 digits. There is controversy as to which digits have been lost. Most anatomists, most ornithologists agree that these 2 have been lost, these 3 have been kept, and these 2 are fused for strength. They are called a major and a minor digit. A major and a minor digit. And this is the index finger, the allular digit, or the first finger. And this first finger is flexible. Major, minor, first finger, okay, or allular digit. And then this construct that has a hole in it corresponds to these bones in your palm, or if you will, the main part of your hand. This is known in a bird as a carpometacarpus. First finger, allular digit, major digit, minor digit, carpometacarpus, wrist, ulna, radius, elbow, humerus. This first finger, let me pause this. The first finger is a very important function to help maintain a smooth flow of air over the wing or the airfoil. And that first finger, when lifted, can lift these feathers, which are known as allular feathers. And by lifting these up, a bird can influence the air coming over the dorsal part of the wing such that it smooths it out and reduces turbulence. So that first finger is a very important function. So this guy has to be non-fused, and it has to freely move. First finger, major digit, minor digit, carpometacarpus. All right. This is the sternum bone, this is the major chest bone, and it's huge. It's one of the biggest bones on a bird's body in terms of its overall size, and that's to afford, if you will, attachment of the biggest muscle on a bird's body, known as the pectoralis muscle, the pecs, if you will, which have very powerful contractions and allow for downstroke of the wing and thrust through the air. So, we've taken care of the forelimb, we've taken care of the hind limb, we've done the pelvic girdle, we did the bones of the legs, and we did the toes. So let's go upstairs. These are the cervical vertebrae. Now a mammal, excluding sloths, has 7 cervical vertebrae. Birds tend to have 13 or 14, and then some birds, like a swan, a sandhill crane, they have sometimes double the number of bones in their cervical vertebrae, and that's to give the bird flexibility. And the reason the neck needs to be flexible is because of this major point. The bill, the beak, has taken over a lot of the functions that forelimbs play in, for instance, reptiles and mammals, where they can pick things up. Birds interface with the environment with the use of their beak, because these forelimbs have been modified for flight. So we're ignoring flightless birds. They're a minority of the 10,000 species of birds. So cervical vertebrae. All right. This part of the skull is known as the occiput, or the occipital bone. These are parietal bones right on the top of the skull. And then right between the eyes, right down here at the base of the bill, near the base of the bill, this is the forehead, or the frontal bone. Frontal, parietals, occipital bones, and the beak is made up of 2 major bones. There's actually a lot of bones here, but 2 major ones that I want you to know, and it's on your handout. Maxilla, or maxilla, and the mandible. Mandible's ventral or underneath, maxilla's on top. Parietals, occipital, frontal, maxilla, mandible underneath. Now, there's several other bones up here in the head. This one right here that's rather diagonal, it's a small bone. This is known as the nasal bone. This long bone right here that's wired shut to the mandible is known as, and it's a tongue twister, it's known as the quadrijugal bone. The quadrijugal bone. And I need to show you what its function is. This is a snowy owl skull, and I wanted to show you the very important function, one of the very important functions, of the quadrijugal bone. That's this long, thin bone. This bone articulates to the rear part, if you will, of the skull posteriorly, and then anteriorly to the corner, so to speak, of the base of the beak. This bone, by being long and thin, renders it flexible. Now, if you watch closely, and if I don't push too hard, I want to point out that, again, the beak is under strong selective pressure to be able to manipulate environment, which means to be able to move it. In fact, birds can move the top part of the beak separate from the lower part, in fact, quite readily. And if you look closely, you'll be able to see the movement of this region of the bill here because of the flex of the quadrijugal. So a very important bone. Okay, so maxilla, mandible, the long, thin quadrijugal. Here's the nasal. Parietals up on the very top. There is a very thin wall of bone known as a septum. Specifically, it's the interorbital septum. Again, I'm using terms that are on your handout. Interorbital means between the orbits of the eyes. I cannot overemphasize this. The main sensory function of a bird's body are the eyes, sight, and they take up an enormous amount of the skull. In fact, it pushes the brain rearward on most birds. So this is a very large opening. The eyes so fill the sockets in so many birds that they turn their heads because they cannot turn the eyes in their socket. It's very important for them to have really good sight because they move very fast. You don't want to run into things. You need to keep track of environmental surroundings. Okay, occipital bone, parietal bones right up on top, frontal bone between the eyes, maxilla, mandible, quadrijugal, nasal, interorbital septum, cervical vertebrae. Okay. Now, I told you there were two sets of ribs, and they're predominantly the obvious vertebral ribs and then the sternal ribs down below. There's one more set of ribs. They are easily overlooked. They are oriented dorsally near the top of the rib cage and anterior. They have no uncinate processes of them. This bird only has one left of a set of two bones. There's one on each side. They're called a cervical rib. So if you look closely, my pointer is touching a cervical rib right here. There should have been one over here. It's just broken off. So this is a cervical rib. This is a coracoid bone. This is a furcula. This is a sternum, and the vertebral ribs. Guys, I've explained in basic characteristics of birds, the first module on Canvas, that this is an airfoil. It's the forelin, of course, and it's all feathered here. And there are pictures, as I recall, that indicate that there are primaries and there are secondaries. Collectively, they're known as remiges, and it's on your lab manual. These feathers here, the primaries, notice they are asymmetrically constructed. There's a central shaft, but there's more feather vein, more filaments oriented rearward than there are surface area of these filaments projecting forward. And because they're asymmetrical like that, here's the primary, the most distant away from the body proper. So here's the central shaft, and here are the filaments. This whole area is called the vein, and here are filaments rearward and forward. So if the muscles, if I was holding this feather like this, and a bird exhibited downstroke, because there's more surface area of the vein rearward, it automatically elevates the rearward part like this. That asymmetry allows a bird then to paddle its way on a downstroke. The upstroke is a recovery. This helps them paddle. Any bird, whether it's fossil or a modern day bird that has a feather imprint that has asymmetry to the vein of the primary, means it was a flyer. Two major flight muscles involved with flying. the most ventral one and the biggest one, when you turn a turkey over on Thanksgiving or whenever you eat a turkey, and you carve through that chest muscle, the muscle that you're going through is the pectoralis. For most birds, it makes up 15% of the entire mass of the whole body. The only greater amount of mass that ever occurs on a bird from a muscle would be the hummingbirds, and they're off the grid. Their pectoralis, that allows them to do some incredible things, is 30% of their overall body mass. But in most birds, the pectoralis is about 15%. Please take note. This is a pectoralis muscle, so is this. And what I've done is I've drawn it, it's attached to the ventral part of the humerus bones. These are humeri bones, the most proximate ones of your body. Because the pectoralis is attached ventrally to the humerus, when the pectoralis contracts, it pulls the humeri bones downward. And it allows those primaries with their asymmetric constructs to paddle the bird, if you will, forward through the airfoil. There must be an antagonistic or recovery stroke. There must be an upstroke. That is affected by the contraction of the next biggest muscle in a bird's body, known as the supracoracoideus muscle. Right here. I encourage you to draw this in someplace on your lab manual. Supracoracoideus. Notice it isn't attached ventrally to the humeri bone. You have these dashed lines, goes up behind, and then attaches on the top of the humerus bones. So the supracoracoideus lifts. It can only do that. Pectoralis contraction brings the forelimbs down. Supracoracoideus contraction, the opposite reaction, if you will, is to pull them up. This is the sternum bone. Here is the keel, the carina of the sternum bone. This is enhanced perpendicular surface area that allows for attachment. There's that surface area that's just so important for the attachment of these large muscles. A point of fact, when you do taxonomy, the second, in effect, module of lecture component, most of the flightless birds don't have this carina or keel or this perpendicularly oriented bone. They have no need for it. They have a more flat sternum bone because they have smaller muscles that are not used for flight dynamics. I want to go over some external topographic features of the bird's body, which will also help you immensely for bird identification and for some of the lecture modules also. So I'm going to highlight some of the features, for instance, that occur on the first couple of pages of your lab manual. And by the way, I do not expect you to know all these names of these different kinds of covert feathers, C-O-V-E-R-T. Covert feathers just cover the bird's body, and these are covert feathers. These are covert feathers. There are really three major flight feather groups of a bird's body. There are primaries and secondaries on the wing. They're collectively known as remiges. So it's this and this. These give paddling or thrust through the air. Secondaries give lift. And then the tail feathers is the third major group. They are known as the rectrices, singular rectrix. Don't worry about the numbering. I don't expect you to know that. But primaries, secondaries, and the allular feathers. Remember, the first finger influences these. But these are just simply covert feathers. That's all I want you to know. And don't worry about scapulars. Unless I emphasize them, you don't need to worry about it. It's the things that I say. So covert, they cover the body. So covert feathers, covert feathers, covert feathers, covert feathers, covert feathers. Any feather that's non-flight externally like that is essentially a covert feather. Now, let me emphasize some body parts. They're relatively straightforward. This is obviously the head, and this is the neck, but the neck has different names of different parts, that is, names for different parts. So the neck has a nape of the neck, N-A-P-E, side of the neck, very technical, side of the neck, nape of the neck, side of the neck, and this is the jugulum of the neck. And again, these are terms that are covered on pages 1 and 2. Side of the neck, nape of the neck, jugulum of the neck. This is the gular region of the head, the massive, most of the ventral part, that is, of the underside of the head. The chin is very small. It's the immediate part just behind where the mandible bone, in fact, or the base of the bill, conjuncts or connects to the head. So this is the gular part of the head, This is the chin. This is the crown. This is the forehead. The frontal bone would be there. This is the crown. This is the frontal bone. And this is the occiput region of the head. Then there are several parts, as you guys can readily see. Before I continue, let me do this. I'm sorry. The center of the upper part of the back, before you get to the neck, is called the mantle. It's a term I'll be using in a lot, relatively a lot, when I describe parts for bird identification. This is the mantle. This is the side of the bird's body. This is the chest of the bird's body externally. Here's the belly. Here's the chest. Here's the mantle. Here's the side. And this is the flank, from where the legs are backward, if you will, toward the underside of the butt region. So flank, side, chest, belly. What bone is here? Tarsimetatarsus. Digit number 4, digit number 3, digit number 2. And in this bird, the halix is elevating its way up here. It's digit number 1. It's actually quite small because they don't, helix bones are longer in birds, especially that are arboreal associated with forest, because it helps them cling to branches. Back, mantle, upper part, center part of the upper back, mantle, side, jugulum of the neck, side of the neck, nape of the neck, occiput region. These are external topographic features. All right. This part here on this bird, all birds have it, but in this bird it's colored yellow. This is called the lories, L-O-R-E, the lories. All right. Every bird has it, but on some birds are colored. This part of the bird's head is the auricular area of the bird's head. And this part, and all birds have an auricular area, and this part is called the malar area, coming back from the corner of the mouth, which is known as a rictus, R-I-C-T-U-S. The rictus coming back. This is the rictus of the mouth, the corner of your mouth, if you will, and this is the malar region. Gular region of the head, chin, auricular, malar, lories. What's the major bone up here? Maxilla, mandible bone. Okay. This is a yellow-bellied sap. This is a yellow-bellied sapsucker, and we're going to do a close-up of the head region to point out some terms that are on the second page of body topography in your lab manual. So, there are 3 areas that terms I use for bird identification, ornithologists use conventionally, and they specify certain specific things, and I don't want them to be ambiguous, so I want to be very, very clear. So, this line that's light colored is called a supercilium. It's at the bottom of page 3 in your lab manual, and you look at the outline of that song sparrow, which is at the bottom of page 3. This is a supercilium. In order for me to use the word supercilium in this class, there must be color variation with the rest of the head, and usually the supercilium is a different color, and it's usually above the eye. It isn't always above the eye, but mostly it is. This line that goes through the eye is called an eye line. Supercilium, eye line. By the way, this area down here would be the malar area. It's colored white, and there's some of it, there's a little bit of black. Okay, so supercilium, eye line. Whenever we use the words supercilium and eye line in this class, there must be color variation. Also, when the term eye ring is used, it refers to color variation, in contrast to the rest of the head, that surrounds either most of the eye or most of the eye. On an adult male American robin, there is an eye ring. It's typically white, and it's often more circumferencing, forgive my verbing, of the entire eye. Guys, I want to say some things about the bill and some areas surrounding such, if you will. Fish catchers, fish pursuers, fish divers like grebes, and this of course is a common loon. They have very strongly elongated bills and have a strong lateral compression from the sides. Ducks and geese have compression from the top and bottom. They're dorsal ventrally compressed. Most birds have laterally compressed bills, and fish pursuing birds have strongly laterally compressed bills. This center of the upper part of the bill on the second page of your lab manual is referred to as a culmen. And in your lab manual, it says it's a ridge. That's not exactly true, so there's a little bit of ambiguity here, and I want to make sure you have this right. The culmen refers to the center line of the top part of the beak. All birds have a culmen. It's just that on this bird, because there's strong lateral compression, it looks to be, and forgive my verbing, ridged. But all birds, even this swan has, and this happens to be a tundra swan, has a central part, medial part to the upper part of the bill. That bird has a culmen. All birds have a culmen, okay? And so it just doesn't mean that it's ridged. Some birds have a cere. Only some birds have a cere. It's a fleshy portion of the base of the proximate portion of the upper part of the beak, which of course this bone underneath here would be the maxilla bone. Parrots have ceres, pigeons have ceres, birds of prey like this subadult bald eagle have them. Again, just certain species of birds, and we'll be doing a little bit of that in our module with taxonomy, happen to have ceres. And nostrils are often inside the ceres, but they don't necessarily have to be. Also, on page 2 for external topography, you'll notice at the bottom here, where they emphasize the cere, the gape is the opening of the mouth. A couple of other terms that I want you to be aware of. Tomia are the edge of your lips, so to speak, analogous. It's the edge of the bill, the very edge. In some birds, there's actually some miniature ridges on them, some lamellae. And you can see these little ridges. They almost look like, I don't know if you can see those, they look like teeth under there. They aren't. Those are just ridges of the beak itself. But they are on the edge of the bill. So the tomia, plural, is the edge of the bill. Tomium is a singular. The corner of the mouth, anatomically speaking, is known as the rictus of the mouth. On many birds, there are feathers that are hair-like, ergo the word bristle, and rictobristles. This is a snowy owl. All of these feathers, it looks like a mustache, these are rictobristle feathers. They have lots of them because it's cold where they're at, and they're rather, again, bristle-like. There are rictobristles. Here, the hair-like, they aren't hair, of course, these are feathers. You can see these very small rictobristles. They have a variety of functions. In some birds, they help protect the nostril from incoming particulate matter. And in some birds, they're sensory, and they can actually gauge, if you will, reverberations of sound, if you will, that's influenced by the motion through the fluid we know as air. So they can be sensory or they can be protective. Hey guys, this is page 11 of your lab manual, and I need to go over some things associated with this and use some terms, etc., so that you can better appreciate the plumage, the feathers that are on a bird's body. There are really only two kinds of feathers at the most basic dichotomy. There are what are called pinnaceous feathers, and they're what are called plumaceous feathers. Pinnaceous feathers exhibit pinnacity, plumaceous feathers exhibit plumacity. And there are really only two feathers on this array. These are the conventional feathers. There are other types, but these are the main feather types on a bird's plumage. There are only two pinnaceous feathers, this one and this one. This is a primary feather. It's a flight feather. It's also known individually as a remix. This is an aftershaft feather. Well, you could also call it a contour feather. It's also a pinnaceous feather. Whenever you have this rigid construct of regimented filaments, those are part of in the constructs that define a pinnaceous feather. These feathers are rather loose in their construct, and they are exhibitive of plumacity. They don't have this rigid. This rigidness in terms of the construct of the filaments provide a defined and non-loose contour, which minimizes turbulence and allows these feathers for flight facets to a large degree. So pinnacity, by the way, will always trump plumacity. Why do I say that? Because this feather actually has some plumacity to it. But notice the pinnacity. Because there's pinnaciousness there, then this is a pinnaceous feather. These have no pennacity, no pennacity, no pennacity. Okay, so let me go over a few parts, and let me drop here, and I've had drawn on the blackboard a primary feather. So look up here, please. This is the flight feather. It's a remix, it's a contour feather, and it exhibits pennacity. Here is the central shaft. The central shaft has two major parts. The calamus, also known as a quill, is the naked part, the base that essentially connects to the bird's body. And there are smooth muscle fibers that hold that feather in place most of the year until the hormones tell it to drop the feather, covered, of course, in a narrative fashion uploaded on your Canvas lecture module. This part of the feather is the vaned part. This is a feather vein, V-A-N-E. All of these filaments comprise the vein. You might recall this is the rearward oriented part of the vein, and this is the anterior part. Notice the asymmetries that renders this as a primary, as a flight feather per se. The central shaft that has the vein, the central shaft is known as a rachis, A-R-A-C-H-I-S, a rachis. And the vein is actually made up of a lot of what are called barbs, and there are hundreds, if not thousands, depending upon the size of the primary feather, or this contour feather, or this remix. They're all synonyms, if you will, for this particular feather. So what I'm going to do is I'm going to take part of this feather and I'm going to blow it up so you can see the parts of the barb. Some of these are macroscopic, and one part is not. So this part right here, this is the rachis, that's this. And this is the distal region of the feather, away from the body. And this is the proximate oriented part of the rachis. This is part of the feather vein, this part. And what I've done here is I've drawn adjacent filaments and I've separated them. I've bastardized the picture so I can show you something that I couldn't show you otherwise. So just to be clear, this particular feather, for instance, this is vein, there are barbs in here, and there are barbs in here. And this is the pennaceous part of the feather. Notice there's a little plumacity here, but pennacity trumps plumacity. Rachis, calamus, and quill. Rachis, calamus, or quill. All right, so here I'm breaking apart part of the feather vein and revealing parts. The parts that are macroscopic, this is a pennaceous feather now, are called a ramus, or rami for plural, R-A-M-I, but a ramus is R-A-M-U-S. That's this and this, two rami. Coming off of each one of those rami, or each one of the ramus, are other filaments, and on a pennaceous feather, they're almost microscopic. They're called barbules, B-A-R-B-U-L-E-S. Here's a barbule, here's a barbule, here's a barbule, here's a barbule. This is the distally oriented barbule, away. These are distally oriented barbules. These are proximately oriented, And on a pennaceous feather, there's a third part to a barb. Barb has three parts in a pennaceous feather. In a pennaceous feather, a barb has three parts: a ramus, barbules, both distal and proximately oriented, and barbicels. The barbicels I've not drawn, and I'm going to draw them right now. They're little hooklets, and they only come off of the distally oriented barbules. They're not on the proximately oriented barbules. So when I go like this, when I disrupt the construct, the contour of this feather, what I've really done is I've detached the barbicels. When I go like this, kind of like Velcro, I don't go too far. I've reattached them, and the feather remains its construct. This feather is a plumaceous feather. This feather happens to be the semi-plume on your handout. Is the semi-plume. Here's a quill. Here's a rachis. Is there a feather vein? Sure. Are there barbs? You bet. But this plumaceous feather lacks one thing in its barbs: it lacks barbicels. It has these two things. I can show you them readily, but it lacks barbicels. No matter what I do, I cannot connect these filaments, these barbs of the feather vein, because there's no barbicels to attach to. If you look closely, you can easily see each ramus, and if you look closely, you can see the barbules coming right off of each ramus, almost like a pinnately compound construct to a leaf. Seeing is believing. On a plumaceous feather, especially this one, that's so big, you can see the ramus, rami, and you can see the little barbules coming off. You can easily see the rami on this vein, but the barbules are so small they're microscopic you can't see them, and the barbicels are microscopic. So, to be further clear, on a pinnaceous feather, the vein is made up of barbs. There's a ramus, there's barbules, and there's barbicels off the distal barbules. A plumaceous feather has only these two parts. So we covered this kind of feather. We talked about a semi-plume feather, and by the way, these occur on birds that are often used for decorative purposes. In fact, we use semi-plumes on costumes, for instance, in plays and vaudeville acts. This feather is called an aftershaft feather. It's a contour feather. These are coverts or contour feathers. Coverts and contour feathers are essentially the same, and I'm touching these. Now, these are the external parts, but actually that feather looks just like this. If you turn this feather over and I was to pull one of these feathers off, here's what the feather would look like. And notice it looks just like feather E, and there's a calamus or a quill, but there are two raci. There are two central shafts. One of them is plumaceous, and the other one has a lot of pinnacity to it. On the outside of the bird's body, you only see this part. So you can ask yourself, why are there two central shafts? To support, to afford lay of the plumage, to provide contour so that the body has a form that will minimize turbulence. So this is a supportive part, but there's also plumaciousness here, which also acts as a thermal facet. Wispy feathers that are plumaceous like this one, they have no construct, they can tend to hold air if they're underneath, if you will, the pinnaceous covert or contour feathers. So this feather provides contour to minimize turbulence. But because there's plumacity here, there's also a thermal adaptive component, an insulative function. This is without question, if not the most common feather on a bird's body. And we did the flight feather, the primary. The down feather. These, now this bird's dead, obviously. These are down feathers. Please note, down feathers have a calamus, a very short central shaft, but there's no rachis. There's a calamus or a there has to be because it connects to the bird's body, but there's no rachis. Are there barbs here? Of course there are. Are there barbules here? Of course there are. Are there any barbicels? No. Barbicels only occur in pinnaceous feathers. Function of this feather type? Insulative. Now, when this bird was alive, these down feathers would be hidden underneath the covert or the contour feathers. They are wispy-like. They tend to trap air. Okay. This feather on the far left is known as a filoplume. This is a relatively small statured feather. And ask yourself, does it have any pinnacity? Nope. There's only two pinnaceous feathers here. So it's a plumaceous feather. Is there a central shaft? There has to be. Is there a rachis? Yes, right here. Is there a calamus? Yes, right there. Here's a calamus. Here's a rachis. Are there barbs up here? Of course there are. Are there any barbicels? There can't be, because there's no pinnacity here. Well, what, pray tell, would be the function of this particular feather type? Filoplumes are sensory. There's a lot of nerve endings that attach to the base of the feather, and they tell the bird about the lay of its plumage without it having to look around and go, oh, my feathers are out of place. These give feel to the lay of the plumage, and it tells a bird that, oh, some feathers are out of place, and I need to preen with my beak to put them in place. So, they're easily overlooked because they're small in stature. But if you look very, very closely here, right at the tip of my feather are several filoplumes. You should be able to see them against this black background. Again, these are sensory. There tends to be a greater density of them at the base of rectrices, tail feathers, because tail feathers are very important for flight and for acting as a rudder. Filoplumes. They also occur, if you will, at the base of primaries. And so there'd usually be a bunch at the base of the primaries. They are giving the bird sensory information. And you might recall there was one other feather type we talked about known as rictobristle, which occurs up near the corner of the mouth. These are the major flight and non-flight feathers that are found on most birds' bodies. Hey guys, we're almost done with this lab stuff. I wanted to make sure that you got to see me verbally go over some of these things, because they are very, very good. Continuing with plumage. Feathers are very expensive, as discussed, for instance, in my lecture module on Daving mold, etc. And because they're so expensive, most birds don't grow them and cannot afford them to grow across their entire body. So they only grow them in certain parts. Yep, there's always some exceptions. Happy feet, the penguins, Veniciformes from Letcher, for instance, they grow feathers everywhere. They're in cold water. They need feathers everywhere, but most other birds don't have such a construct. So if you look at page 12 in your lab manual, you'll notice that there is a construct that shows the portions of a bird's body, the skin, that feathers emanate from or grow from. And this is very, very common for most birds. This happens to be a songbird, and I'm going to use this bird, a nestling bird. This is not a songbird, this is a pigeon, also known as a squab in a colloquial term. By the way, excellent eating if you make a squab. Weber gruel, red onion, and of course a dollop of butter. Not designer butter, regular butter, the good stuff. So, there's a dorsal view and a ventral view. These terms are pronounced in the following way. Pterale is a feather tract. It's a place on the skin where feathers grow from. Aterale means naked portion of the bird's body, the white part, the skin where feathers do not grow from. Here's an aterale. Here's an aterale. And by the way, not only these adapted because you don't have to grow as much feathers because they're expensive, but also a bird can raise their feathers and expose this naked skin, and they can readily allow themselves evaporative water loss by allowing water to essentially leave their body vis-a-vis the skin. Mostly songbirds do it by panting, but this is an auxiliary way to be able to get rid of excess heat. So please take note. These are the standard feather tracts, or pterale. Plural is pteria, singular is pterale, from which the feathers grow from. On the top of the head is called the capital feather tract, or pterale. So that would be right here. Continuous with that plumage growing on the top of the head is a line coming back. And you'll see it right here going over the backbone, if you will, or the spine. And it's known as the spinal pterale. And you're thinking, oh, wait a minute. Aren't there two lines here? Well, there's always exceptions. A lot of birds have a single line going back, and some birds have a bifurcation like this. It's still a spinal pterale, spinal feather tract. The tail feathers emanate off of what is called the caudal feather tract, or pterale. The wings, when they're held outward like this, have two pterale on them. Anteriorly, and in association in part with the humerus bone, ergo the name, is the humeral pterale. And posteriorly is the alar pterale. This is where the primaries and the secondaries, for instance, as many of the covert feathers would emanate from. And covert feathers also would occur off of here too. So this is the humeral, this is the alar. Ventrally, there is what is known, so let's flip this bird over. This is the ventral pterale. It is standardly, if you will, bifurcated, so there's two major parts to such. And then the two remaining pterale are the femoral or femoral, or the crural, and spelled C-R-U-R-A-L. Those are in association with the flank and the leg. Now, the femoral or femoral terale is associated to a certain extent with the femur, but it's not on the leg. So please remember it this way. F, flank. That's this portion of the bird's body back from the leg and toward the butt. And notice these light and gray white feathers. They are coming off of the femoral or femoral, F for flank. Feathers coming right off of the leg, those come off what is called the crural terale. So the feathers on the leg are the crural terale. Feathers in the flank region are the femoral. Caudal coming off the tail, spinal coming off dorsally, and of course the capital as a mini review. So those are major things I wanted to cover. Let me quiz you on a couple of things for just a minute or so to get you into the pattern, so to speak, or the mode of being able to use these terms, which will serve you very well, both from a lab perspective and from the lecture when we cover the taxonomy of birds. So let's do a quick review of some of these bones here. Tibia tarsus, ankle, tarsimetatarsus, digit number 3, digit number 4. The hallux, known as digit number 1. The sternum, lots of surface area for the major downstroke of the pectoralis muscle. Cervical vertebrae, maxilla, mandible, parietal bones, ilium, synsacrum, 3 caudal vertebrae, ischium, pubis, vertebral ribs with their uncinate processes, sternal ribs below, coracoid bone, furcula or wishbone, scapula bone, semiplume. Is this a pennaceous or a plumaceous feather? Plumaceous. Are there barbs on the vein? Sure. Are there barbicels in those barbs? No, there are not. Rachis, calamus, or quill. Mini review. Supercilium line over the eye. Now notice the light color variation, or the variation in color from the rest of the head. Dark area, eye line. Supercilium. Does this bird have a supercilium line? It does not. There's no color variation. All right. Eye ring. Color immediately surrounding the eye, like on this roadrunner. Cere. Cere. Bones at the top of the head, parietal. Wrist of the wing. Covert feathers. Flight feathers. Primaries, pennaceous feather. Rectrices, the tail feathers. They're also contra feathers. All pennaceous feathers are also contra feathers too. Covert feathers. Chest. Belly. Major bone, right here. Tarsimetatarsus. Digit number 4. Digit number 1. Culmen, the center of the upper part of the beak. Mandible bone. Does this bird have a supercilium? Nope. Does it have an eye ring? Nope. Does it have a lories? All birds have a lories. It's this portion from the anterior over the eye to the base of the bill. All birds have a lories. But in some birds, lories are colored. Side of the neck, jugulum of the neck, gular region of the head, mantle, center of the upper part of the back, back. Here's a couple of tidbits, no extra charge. This is a tail feather, so it's a rectrix, part of the rectrices. It came off an adult Merlin falcon. You'll notice that there's a dark region of the feather. That's where there is melanin. It's a structural pigment. It doesn't come from dye. It's the way the the cells of the keratin construct are spatially organized that tend to reflect this dark light. I want you to know this. Where there's melanin, the feather is stronger. Where there isn't melanin, where it's light colored, it's not as strong. So if you come here close up, this is a very old feather. You'll notice where the melanin is lacking, that feather is starting to degrade faster. No surprise that at the tip of many primaries they're dark, because that part of the feather might physically hit something. So you want to have it a stronger portion, if you will, to the outside. And by the way, the dorsal part of the feather, which gets bombarded by solar radiation, tends to have more melanin than the underside. So look closely. Look at the rachis. See how dark it is? It's almost black. Look how much lighter colored the rachis is, especially when you get down here. It doesn't need as much protection underneath because the sun doesn't reach that portion. Also, beaks, very important. The cervical vertebrae, and the reason there's so many cervical vertebrae compared to a mammal is so that the head can turn readily. And the beak has to be lightweight. There's no teeth. This bill is on a toucan, and this bill, I wish I could show you this in person, you could hold this. It is as light almost as a proverbial feather. And by the way, if I was to take this owl, this is a great horned owl, pluck out of the 4,000 to 5,000 feathers that are on its body, the feathers would weigh more than the endoskeleton. Endoskeletons are light. A bird has dumped all excess bones it does not need. No long bony tail, no, if you will, teeth, and it got rid of 2 digits in the forelimb, and what's left, a couple of those things are fused. The head has to be very flexible. This is not a bird skull, it's a mammal skull. And in fact, this animal head has some antlers. This is the occipital region of the head, but I draw your attention down here on the underside. These are called, and you don't need to know this, these are just no extra charge. These are called occipital condyles. And these 2 bone constructs, or struts, are the things that articulate with the uppermost cervical vertebrae in our necks, which is called an atlas. Again, I won't test you on this, I just want to emphasize this. Mammals, like you and I, have 2 occipital condyles. They're laterally placed here, and they allow for a rather rigid, yet some flexibility, of course, to maintain the integrity of the skull articulating with the cervical vertebrae. This would limit a bird's mobility of its head. So instead, this is a snowy owl skull. They have gotten rid of one of the occipital condyles. There's only one. It's quite small, and it's circular. And it allows the skull to float more readily on top of the atlas, which is the uppermost cervical vertebrae in a bird's body. This gives the head tremendous flexibility.